I'm going to work a few problems from the second trig test where we're graphing sine and cosine curves and doing those transformations. I'm going to work a few problems from that review. This is going to be number 1C. Okay, so before you even get started, you should be able to look at this problem and kind of see what's going on and where you're headed. You know that there's going to be a horizontal shrink or stretch because of the fact that there's a number in front of x. Okay? And you know that there is not going to be any kind of a vertical stretch or shrink because the number in front of cosine is 1. You know that there is not going to be a horizontal shift left or right because there's no parentheses here and nothing is being added or subtracted to the x within the parentheses. And you know that there's going to be a vertical shift up 1 because of this plus 1 out here to the side. If you can't identify those things right off the bat, you're probably in a little bit of trouble. You need to make sure you're studying. So the first thing that I have to do is I have to find my new period. Because of the fact that I have a horizontal shrink or stretch here because of this 4, because the value b is 4, that is going to give me a new period. And the period is equal to 2 pi divided by b, which in this case is going to be 2 pi divided by 4, which is pi halves. So my new period is pi halves. So I'm going to graph that cosine curve over the period pi halves. Now, something that we need to talk about, I haven't really emphasized too much, is that your note card tells you that these sine and cosine curves, their range is from their domain is from negative infinity to infinity. Okay, that means that it goes on forever to the left and forever to the right. But we're only graphing one period of these functions. Okay, so what I have is my period is pi halves, so I come out here to the right and I mark that pi halves. Then I divide this space up into 4 equal parts. And notice that my parts aren't perfect. Yours may or may not be perfect. Just get it as close as you can. Just kind of divide it into 4 parts. Okay, then we're going to go ahead and we have 1, 2. You might just start out with 1, 2, and 3. Then -1, -2, and -3. And I want to graph cosine. Okay, well, if you recall, now what I'm about to draw right here is not part of my problem. If you recall, the parent cosine function has a period of 2 pi. It starts up here at +1. And it comes down to here, down to here, up to here, and then back up to here. And it looks like that. Besides, it goes through those points. Even though my period in my problem over here has changed, and these critical points, which this one is 0, 1, this one is going to be pi halves, 0, this one is pi, -1, and so forth, that I told you to put on your note card. Those ordered pairs changed, but the relative position of those pairs, based on how you divided this period up into 4 equal parts, stays the same. It still starts at 0, 1, then it comes to here, then it comes down to here, then back up to here, and back up to here every time. And you need to be able to sketch that out before you can do this transformation. Okay, so here's cosine over the period pi halves, and my transformation is, well, I've already taken care of this 4 because that changed my period, and that's done. Okay? There's nothing to multiply the y values by. There's no reflections out here in the x-axis. There's no horizontal shift left to right. All I have to do is go up 1. So up 1 for each point. And that's it for that problem. It's done. Let's take a look at another one. I'm going to take a step back and I'm going to do B. This is 1B. So you should be able to look at this function, this equation here, and tell that, well, my period's 2 pi. I know that right off the bat because there's nothing in front of the x other than a 1. You know, we know there's a 1 in front of there. But there's nothing in front of the x. The period is still 2 pi. I'm going to shift left pi over 4 units. I'm going to multiply the y values of each ordered pair by -1. Which reflects it in the x-axis, and then I'm going to go down 1. You need to be able to recognize that. So when the period doesn't change from the parent function, or when the period is still 2 pi, I'm just going to trace out my parent function first. So my period over here is 2 pi, which means this is pi halves, pi, and 3 pi halves. And I've got sine, and it looks like this. Should be getting pretty good at putting these points for sine and cosine and tracing through this graph. And there it is. So now all I have to do is my transformation, and I'm going to do it in this order. I'm going to go left pi over 4. Okay, if I've got to go left pi over 4, I need to know how far that is. And I'm not going to have room to write all this, but if this is pi halves, then right there in the middle is pi fourths. I'll write it down here to kind of review. I've already talked to you about this, but I'll do it again. So this blue mark is 1 pi over 4. This is 2 pi over 4, which is pi halves. Then this is 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi halves, 7 pi over 4, 8 pi over 4, which is 2 pi, and since I'm going left, if this is pi over 4, then over here this is minus pi over 4, and that's all the values I need. So now I can do my transformation. So each point is going to go left pi over 4, y value times -1, and then down 1. Left pi over 4, y value times -1. The y value of where my pencil is at is 0. 0 times -1 is 0, so it stays there, but then I go down 1. That point goes to there. Left pi over 4, y times -1. 1 times -1 is -1, so I'm down here, and then down 1, I'm right here. Left pi over 4, y times -1 stays there, down 1 goes to here. Left pi over 4, y times -1. -1 times -1 is +1, so I'm up here at the +1, but then down 1, I'm right here. Left pi over 4, y times -1 stays there, then down 1 goes to here. Now let's trace it out using that same way that the sign looks, and there's your answer right there. So I've done 2 examples so far. The first one, my period changed. The second one, my period did not change. So make sure that you know what's going on, and yes, this negative sign out here means it's a reflection in the x-axis, but if you just multiply the y values times whatever is out here, then that'll take care of the reflection. And if there's another number out here such as 2 or 3, that'll, if you multiply it by the negative 2 or 3, that'll take care of the vertical shrink or stretch, and it'll also take care of the reflection at the same time. And I'm going to take a look at one more problem. Let's look at E. I may do 2 more. So this is 1E. Okay, so I take a look at this and I say, well, my period's 2 pi because there's nothing other than a 1 in front of x. I'm going to go right 2 pi units, and I'm going to multiply the y values by half. So since my period's 2 pi, I just start with my parent function. There's my sine curve over the period 2 pi. Now I can do my transformation. Since I'm going to go right 2 pi, I'm going to need a little more space over here. So we had 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, 8 pi over 2, which is 4 pi, and that's all I need because my farthest right point is going to go to here. So here we go. So I'm going to go right pi over 2, then I'm going to multiply the y value by half. So this point, right pi over 2, comes all the way over to here. The y value is 0 times half stays there. Right pi over 2 comes to here. The y value is negative 1 times 1/2 is negative 1/2, and I come to here. Right pi over 2, I'm sorry, right 2 pi rather. I come to here. The y value is 0 times 1/2 stays there because the y value at that point is 0, and 0 times half is 0. Right pi over 2 comes to here. Y value is 1 times half is 1/2. Right pi over 2, y value is 0, stays there, and sketch it out. That's it. And so what I have here is basically it was shifted to the right 2 pi units, and it had a vertical shrink, flattened out a little bit. And I am going to do one more, and I am done. Let's take a look at number 7. I'm sorry, F. This is 1F. Okay, so right off the bat, I can tell you that my period is not 2 pi because I have something in front of the x that's not 1. So I have to find my new period. Period is equal to 2 pi divided by b. And when it's a fraction, when b is a fraction, it might be a little bit easier to look at it as 2 pi divided by b this way. So that's going to be 2 pi divided by 1/2. Keep switch flip, so that's 2 pi times 2 over 1 or 2, which is 4 pi. So my new period is 4 pi. So I just go back and make my function, instead of the parent cosine function over the period 2 pi, it's going to be over 4 pi. Now, something that I'm not explaining here, which we've talked about a lot, I should mention. When you change your period, you divide this into 4 parts, and this first part you find it by multiplying the period by 1/4. So this would be 1/4 of 4 pi. This piece would be 1/2 of 4 pi. This piece would be 3/4 times 4 pi. And then obviously that's 4 pi. But 1/4 of 4 pi is pi, half of 4 pi is 2 pi, and 3/4 of 4 pi is 3 pi. And again, when your period changes, your parent function, the critical points, those ordered pairs where they cross the x-axis change, but the relative position does not. So cosine still starts up here, comes to here, in the middle, the halfway point, it's down at -1, back up to here, and to here. Sketch it out. There's my cosine curve over the period 4 pi. Now all I have to do is go left pi, multiply the y by 2, and go down 1. If I'm going to go left pi, I'm going to need some space over here. If this is pi, then this first mark over here is negative pi. Now I can do it. So, left pi, y times 2, the y is 1, times 2 is 2, and then down 1, I go right back to here. I'll do that again. Left pi, the y value is 1. 1 times 2 is 2, so I'm up at the positive 2, but then my vertical shift is down 1. Left pi, y times 2 stays here, down 1 goes here. Left pi, left pi, y times 2, -1 times 2 is -2, and then down 1 is down here at the -3. Left pi, the y value stays there because it's 0. Down 1 goes to here. Left pi, y times 2, 1 times 2 is 2, is here, but I go down 1, so I'm back to here. Then I sketch it out. And that's pretty much it. Make sure that you can do all these problems. If there's anything you couldn't do there, make sure you study. But as much practice as we've had over the past few days, you should be good to go.